I'm going to discuss the second type of reaction, which means now we are done with the zero order reaction. Now I'm going to discuss the second order reaction today. And we're also done with the first order reaction. So let's second order reaction. Second order reaction. What does it mean by second order reaction? Let's see it. So let me increase the size of the font so that we more visible. Perfect. This perfect. In a second order reaction, what happens is that in the second order reaction, the rate of reaction, which means R in the second order reaction, R O R, which means the rate of reaction is equals to K. K is a rate constant, and K and A with the exponent 2, which means it is the order of reaction is 2 here, right? The order of reaction that is written here is 2. Here rate of reaction is directly proportional to the concentration of reactant with exponent 2. So this is second order of reaction. And after we know that, we can do there one more formula for writing a rate of reaction is this R O R, which means the rate of reaction. I guess it can start. So that's something like this. Okay, let me just try be with it. I will be with it. I will facing difficulty while writing it. So this is 1 by 1 dt. This for instantaneous rate of reaction, right? We can write it like this as well. Now this is a certain. Okay, let's do a derivation of it. How we can derive the formula for the second order reaction? Although this is a logarithm formula, which is very important for what? For actually for the graph purpose. So let's just derive the formula here. So let's go for it, right? So let's take this marker with the dark color. So we know that the rate of reaction, I've just written ROR is equals to rate of reaction. Now in the next video we'll discuss the second order reaction. Graph is equals to with the A raised to power 2. This is a second order of reaction, right? And there is one more other way of writing this reaction as well that I have just discussed is this ROR, same something like the same, is equals to minus 1 divided by 1 D with the concentration of A divided by dt power, right? So this is a certainly two ways of writing the second order of reaction. Now what happens is that right hand side compare with right hand side. Let's do the solution of left hand side, right? So maybe I might have mistaken the difference that is either side or left. So I'm just writing here A with the exponent power 2, and that's equals to minus it's like something like that. So like putting that concentration with the square bracket and inside that the exponent raised to the exponent. Okay, let me just try it. Okay, I might have mistaken it. Let me just see it. Yeah, let's just try it. Let's try it. Yeah, divided by dt. Now just collect the A term on one side while the other terms on the other side. So they will be something look like this. When you do the solution, they will be something like this. Okay. Uh, Now we're gonna do this is kdt shifting this here, which means we'll multiply, is equals to it's equals to dA divided by dt. dA divided by dt. Like, let me just move a little down so that we can explain you more better, right? So let's move a little down for it. We'll come back to this point as well. Okay, now what I want to do this integration, which means we know that the concentration is A naught, which means the initial concentration is A naught at the time when time is equals to 0, right? When time is equals to 0, equals to A when time is equals to T. Remember this thing. Okay. So now we're going to do the integration. It's something like this, integration. Let's take a different marker for writing integration formula, and then we write here dA divided by dt, dA divided by dt. Let's close it, and then here the minus k comes out because it's constant quantity, and like time goes to t to 1, t1 goes to 1, and we write in here t. Then after while it will look something like this. The second or first order reaction we take log. So after while it will look something like this, log e. Although we are not familiar with this log e, we are mostly familiar with this log 10, then it will be something like this, log ea. After log ea, it goes from concentration a naught to a naught. It goes from a naught to a. Is it perfect? Yeah, it's perfect. Let's move a little down to describing it. Until we are done with the solution, we have to move down, down, and down. So let's go. So now what's going to happen is there is something which is equals to minus k, t minus t goes from 0 or t to 0, right? And when you're going to open the formula, it will look something like this. Log, it will be something like this. Log e a minus e naught, log e a minus log a naught, log a naught is equals to k t minus 0, which is equals to kt. And after simplifying the formula more, we will do something like this. Let's go a little down more. I'll be explaining you the graph simultaneously, how we can use this graph. Making the graph here, it's like something like this. Log a log 10a, which equals to log, okay, log ex is equals to, I'm writing here for conversion purpose, you can remember it. Log ex is equals to 2.303 log 10. 2.303, remember it, 2.303 log 10, log 10, right? So the formula will be something like this. Log a equals to log a naught, I'm writing here log e naught, like something like this, log a naught minus kt divided by 2.303. This is the final formula which we will be using for solving the numerical. Not right? No, not solving the numerical. I'm kind of mistaken. So that's equal to this for graph purpose. Let's just move up again. We are done with the formula derivation. So let's deal with the numerical now. Okay, let's erase it. Now I'm going to discuss the not numerical, so for graph. How I have drawn the graph. I can draw the graph with the equation that I have derived. Oh my god, what's happening? I don't know. So we know the equation what I have just derived is that log a is equals to log a naught log a naught log a naught log 10a, which means like log a naught or log 10 minus kt divided by 2.30. Simplify it a little more, 2.303. We need to simplify it a little bit more. It's like something would look something like this, which means log a is equals to minus minus 80 divided by 2.303 plus log a naught. I have just simplified a little bit, so this is something like this. And now we're gonna compare it. Something you can write it that y is equals to mx plus c. This is basically a formula of the graph, which means the where m represents the slope, x-axis and interruption. This represents the interruption. So I'm not drawing anymore. I'm just telling you here. So is there any need to draw it? Okay, let's just do it. Okay, we'll draw the graph. So I'm drawing graph. Let's move a little down so that I can draw a graph. This is yes. Wait. This is a graph. In a y-axis, what's given at the y-axis? Let's move a little up so that we know what's given on the y-axis. Okay, perfect. So now what's given on the y-axis? We know. Wait for a while. Yeah. At the y-axis, we know log a is given. So here we like log a. Like log a is given here. Then the x-axis is given y is equal to mx. In the x-axis we have time. There is interruption, something like started from here, which is given log a naught, initial point log a naught, and the negative slope, which means it goes something like this. Negative slope, as you can see here, it's a negative slope, and slope represent k divided by minus k divided by 2.30. This is a graph of the first order of reaction. But remember one thing, there's one more graph of first order of reaction. Let's erase it. Let's go up. This is a graph that I was discussing now. Right. And there's one more graph. If you want to draw this graph, this is a straight line graph drawn something like this. If you want to draw the graph of this equation, it's given here, it will be something like this. This is y is equals to mx. Y is equals to mx. Y represents rate. Rate represents rate. X represents concentration at a square. And then the graph that will be drawn will look like something like this. It goes, this is the interpretation, and it goes something like this. So this is basically a